Hello guys, this is Swad. Today we'll learn about type of machine learning, mainly the supervised learning. Here we can see there are three types of machine learning. First of all, supervised learning, unsupervised learning, and reinforcement learning. Beside it, there is another type of machine learning, which is self-supervised learning. Today, I only discuss about supervised learning, and next, I will make dedicated video on unsupervised learning and reinforcement learning. So what is supervised learning? Supervised learning is a type of machine learning where the model is trained on level dataset. That means the dataset contains predefined outputs. But in unsupervised learning, the model trained on unlabeled data. It doesn't have any kind of label dataset. In reinforcement learning, the model learns by trial and error. The computer or the agent interact with an environment, takes action, and get rewards or penalties. The main goal of this learning to learn a strategy or a policy that maximizes reward over time. Previously, I mentioned that supervised learning is a type of machine learning where the model is trained on a labeled dataset. Here we can see the apple is labeled as apple and a strawberry labeled as strawberry. So in supervised learning, it learns with answer or the label. The computer is given both the input and the correct output during training. The main goal of this learning to learn predict outputs for new inputs. Think of a teacher in a classroom. The teacher gives you questions and the correct answer. You practice with them until you learn the pattern. Later, when the teacher gives you a new question, you can guess the right answer. This is supervised learning, where the model or the computer learns from the data with answer or the label. Now, if we look in unsupervised learning, we can see there are no label data. All the fruits are remain unlabeled. So in the unsupervised learning, no labels provided, only input data is given. That means the dataset doesn't contain predefined output, no target variable. The system tries to find hidden patterns, structure, or grouping within the data on its own. So in unsupervised learning, the model learns without answer, the computer only gets input data, no correct output, and the goal to find pattern, groups, or structure in data. If I give an example, think of a student without a teacher. The student only gets questions but no answer. They try to find pattern on their own, like grouping similar things. This is unsupervised learning, where the computer or the model only gets data without answer and organize it. The goal is for the model to discover the relationship between inputs and outputs so it can make accurate prediction on new and unseen data. As the image illustrates the supervised learning workflow using apples and oranges as an example, let me explain it. Firstly, we can see a label dataset. We start with a set of fruit images where each one has a label, apple or orange. This is label data, meaning we already know the correct answer for each example. Then the training phase. In training phase, the label dataset is fed into a machine learning algorithm. The model learns to recognize the pattern, the color, the shape, texture of the fruits that distinguish apple from the orange. Then the test data. After training, we give the model new unseen image of fruits as test data to check if it learned correctly. Finally, the prediction stage. The model uses what it learned to predict the labels for the test image. If it sees a red round fruit, it predicts it as apple. If it sees an orange colored fruit, it predicts orange. Now, let's think about what happens if we give our trained model something it has never seen before. Now, here is the catch. What if I show it a banana as test data? The banana was never part of the training dataset. The model has no idea what a banana actually is. Most supervised learning models are what we call forced choice classifier. That means they will always assign the input to one of the known classes, even if it is completely different from anything they have ever seen before. So in this case, the model might label the banana as an apple or an orange, depending on which one things looks more like. So why this happened? Because the model's knowledge is limited to the training set. If the training data set only had apples and orange, the model doesn't even know that a third fruit, a banana, exists. And unless we specially design the model with an unknown or other category, it can't say I don't know. It always guesses for what it already knows. Method to handle the drawbacks. First of all, expand the training dataset. Include more categories in your level dataset so the model learns a wider variety of classes. Example, if you want to recognize banana, add enough banana image labeled as banana during training. Number 2, introduce an unknown or other class. Add a special category for samples that don't belong to any class. Train the model with diverse unrelated examples in the unknown class so it learns to say, I don't know. Number 3, use outlier or novelty detection. What does it mean? Before classifying an input, the system first checks, does this input look similar to anything I have seen before? If it looks very different, the model doesn't force a wrong classification. Instead, it flags it as unknown or unrecognized. Example, assume your model is trained on apple or the orange. Now, input is dragon fruit. Without outlier detection, the model is forced to say apple or orange. That is totally wrong decision. With outlier detection, the model says this fruit is too different. That means unrecognized. How it works? Model learns normal pattern of known classes. For new input, calculate distance or similarity from known data. If distance is higher than threshold, mark as outlier or novelty. There are some common techniques which are used here, like isolation forest, on-class SVM, autoencoders. Why it is important? Prevents wrong prediction, improves system safety, and it is very important in medical security and AI system. Then comes to open set recognition model. What does open set mean? Most ML models assume all possible classes are already known, which refers closed set. But real life it is not closed. Open set recognition means model can recognize known classes and reject unknown classes. As an example, training classes apple, orange, but in the testing, apple are recognized, orange also recognized, but if we give banana as test dataset, it will be rejected or flagged unknown, instead of misclassifying banana as apple or orange. Finally, transfer learning and continual learning. This learning is very faster and smarter. So what is transfer learning? Instead of training from zero, start with a predefined model that already knows general feature. If I give an example, a predefined model already knows shape, color, age, texture of the fruits. Now we have to fine-tune it to learn what is apple, what is orange, and what is banana. Why it works? because early layers learn generic feature, not task specific one. Then continual learning or the lifelong learning. Continual learning refers model learns new classes over time without forgetting old ones. For example, if we keep apple and orange on training dataset, later add banana, model should now know apple, orange, and banana without retraining from the scratch. We added banana, but the model is not retraining from the scratch, but it can predict the banana. So that's all about my today's video. Thank you everyone for hearing me patiently.